Hi guys. Okay, today we're going to talk about real zeros of polynomial functions. So the first thing we're going to do is we're going to talk about long division. Okay, so we want to take this polynomial 6x to the third minus 19x squared plus 16x minus 4 and divide it by x minus 2. Okay, and we're going to do that by using long division. Okay, so we're going to rewrite it like a regular old division problem. Just like this. Okay. Now, I'm going to ask myself, what am I going to multiply x by to get 6x to the third? And that would be 6x squared. 6x squared times x is 6x cubed. This works exactly the same way regular old long division does. Okay, now 6x squared times negative 2 would be negative 12x squared. I need to make sure I line this up. Okay, and then I got to remember that I'm going to subtract this stuff, so I'm going to change all the signs. This should always go away, or I got the wrong number here. Okay, so this becomes negative 7x squared. Bring all the rest of it down. Plus 16x minus 4. Okay. Now I'm going to ask myself, what am I going to multiply x by to get negative 7x squared? And that's going to be minus 7x. Negative 7x times x is negative 7x squared. Negative 7x times negative 2 is 14x. And then you got to remember, I'm subtracting this, so I'm going to change the signs. Okay, so this goes away, as it should. This becomes 2x minus 4. Okay? And now, what do I got to multiply x by to get 2x? That would be 2. 2 times x is 2x. 2 times negative 2 is negative 4. Then I got to subtract. I change the signs, and I end up with 0, which means that it divides unevenly. Okay, so this equation divided by x minus 2 equals 6x squared minus 7x plus 2. All right, let's do a different. Let's take a look at some other stuff here. The division algorithm. If f of x and d of x are polynomials, such that d of x is not equal to 0, then the degree of d of x is less than or equal to the degree of f of x. Okay, so what that says is, if I'm looking back at this one, here was my f of x, okay, and then I divide it by this, I'm going to get something that is a degree less than this. Okay. There exists unique polynomials q of x and r of x such that f of x equals d of x times q of x plus r of x. Okay, so basically this is my divisor, my quotient, and my remainder. Okay, so if I go back and I look at this one here, here is f of x. Here is my quotient, that's q of x. This is my divisor, that's d of x. And there is no remainder on this one. The remainder is 0. Okay. It can also be written like this. So if I did have a remainder, let's say I went back to this thing, and let's say I had a remainder at the end of this thing, I would take whatever the remainder is, I'd go plus, and I would put it over x minus 2. So if my remainder was, say, 3, I'd go plus 3 over x minus 2, and that would be my answer. Okay, let's divide 8x cubed minus 1. Now I'm going to leave a space in between here because even though there's no x squared or x term, when I divide it, there might be those things in here, so I want to leave room for them. Okay, what do I got to multiply 2x by to get 8x cubed? That would be 4x squared. 4x squared times 2x is 8x cubed. 4x squared times negative 1 would be negative 4x squared. Okay, you can see when I subtract this thing, there's now going to be an x squared term here. That's why I left the space here. bring down the rest of the equation. Okay. Now, what do I got to multiply 2x by to get 4x squared? How about plus 2x? 2x times 2x is 4x squared. 2x times negative 2, or negative 1 is negative 2x. Okay, draw my line, subtract, and I'm going to get 2x minus 1. Oh, then I can see 2x minus 1 is going to go into 2x minus 1 one time. Plus 1. So this one divides in evenly also. Okay, no remainder. All right. I'm going to do this one also by long division. Now, here's the thing. This, I should rewrite this, and I want to rewrite it from the biggest power to the smallest one. So 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2. And I'm going to divide it by x squared plus 2x minus 3. Now, we haven't looked at one like this yet. This has got 3 terms out here, but it works the same way. In fact, if you want to, why don't you go ahead and pause this, give this one an attempt and see how you do, and then jump back on and see if you get the same thing I do. Okay, so I'm going to ask myself, what do I got to multiply x squared by to get 2x to the 4th? That would be 2x squared. Okay, 2x squared times x squared would be 2x to the 4th. 2x squared times 2x would be 4x cubed. And 2x squared times negative 3 would be negative 6x squared. Okay, so I got to make sure I multiply each of the terms. All right, then I'm going to go ahead and subtract, so I change all the signs. This goes away, this also goes away, and I'm left with x squared plus 3x minus 2. Okay. Now, what do I got to multiply x squared by to get x squared? How about 1? 1 times x squared is x squared. 1 times 2x is 2x. 1 times negative 3 is negative 3. Then remember, I'm going to subtract this. And I'm going to get x plus 1. Okay, now, x squared doesn't go into x plus 1. So I have a remainder on this one. So I'm going to go ahead and add x plus 1 over this. X squared plus 2x minus 3. And here's my answer right here. Okay? Hopefully that's what you got. Okay, synthetic division. All right, so synthetic division can only be used when you are dividing by something of the form x minus k. So it could be like x minus 2, x minus 5, it could be x plus 3, okay? But if there's an x squared or in there anywhere, or an x cubed, you cannot do synthetic division. Okay. So, excuse me just a second. Okay, sorry about that. Had to pause. Had a little frog in my throat there. So, all right, so here's what I'm going to do. Whatever my x minus k is, I'm going to take the opposite of this. So that's going to be k, and I'm going to put it here. I'm going to write the coefficients of my polynomial down here like this. If I'm missing one, like if I'm missing an x squared, I'm going to go ahead and put a 0 in for its space. Okay? And then essentially what I do is I just go k, I drop my a down, I go k times a would be ak, and then I add these up, this would be b plus ak. And then I would multiply this by this, and it would go here, so in this case that would be bk plus a k squared. And I would add these up, and so on, and I keep going, okay? Not sure I really like this model a whole lot here, but that's what we're going to do. So let's take a look at one like this. I'm going to use synthetic division to divide this. So the first thing I'm going to do is I'm going to write down my coefficients. Now I got an x to the fourth, the coefficient is 1. I don't have an x to the third, so I got to put a 0 down. I got an x squared, I'm going to put a negative 10. I've got an x, that's a negative 2, and then my constant is 4. I'm going to bring this first number down. Now I look at this, I'm going to divide by x plus 3, so I'm going to put a negative 3 here like this. Okay, now I'm going to go negative 3 times 1 is negative 3. I'm going to add this up, I get negative 3. Negative 3 times negative 3 is 9. I add this up, I get negative 1. Negative 3 times negative 1 is 3. I add this up, I get 1. Negative 3 times 1 is negative 3. I add that up, I get 1. Now, if I get a 0 at the end, okay, that means it divides unevenly. In this case, this has a remainder. So, what does this mean? What does this jumbled bunch of numbers mean here? Well, I took an x to the fourth, a degree 4, I divided it by a degree 1, so this is going to be degree 3, which means this is going to be x to the third minus 3x squared minus x plus 1 plus my remainder is going to be 1 over x plus 3. That's going to be, I could do it by long division, but in this case, you can do it quick and easy using synthetic division. Okay? I like the way this is written, so let's fix that. Okay. Let's look. You know what? Let's do another one. Let's do, for additional practice, let's do 2x to the fifth minus 4x to the third plus 7x squared minus 4 divided by x plus 5. Actually, let's make it x plus 2. Okay, so what am I going to do? I'm going to go ahead and I'm going to take this polynomial and I'm going to write my coefficients. So 2, I don't have an x to the fourth, so I'm going to put a 0. I got an x to the third, that's negative 4. X squared is a 7. I don't have an x term, that's going to be a 0. A negative 4. Over here I'm going to write negative 2. I'm going to drop my 2 down. Okay. So why don't you pause the video here, give this a try and see what you get. Okay, so negative 2 times 2 is negative 4. Add this up, I get negative 4. Negative 2 times negative 4 is 8. Okay, add that up, that's 4. Negative 2 times 4 is negative 8. Add that up, I get negative 1. Negative 2 times negative 1 is 2. Add that up, I get 2. Negative 2 times negative 2 is negative 2 times 2 is negative 4, and I get negative 8. I thought I was going to get lucky for a minute, and that was going to all cancel out, and with no remainder, that would have been kind of cool. Okay, so what's my answer? I started out with an x to the fifth, so that means this is 2x to the fourth minus 4x to the third plus 4x squared minus x plus 2 minus 8 over, what was it, x plus 2. This is my remainder. That's my answer. So it saves you kind of a bit of writing from doing long division. Okay? Like I said though, if this is anything other than like x plus a or x minus a, you can't do synthetic division. Okay, so using the remainder in synthetic division, in division, okay, so the remainder r gives the value of f at x equals k. So if I look back here, okay, this is x minus k, so k would be negative 3. Okay, we didn't really talk about the remainder theorem. We'll actually do that next lesson. If the remainder is 0, then it's a factor of f of x. So what that means is if I get 0 as a remainder, that means this is a factor of that. It divides evenly in there. Okay. If r is 0, then k0 is an x-intercept of the graph. So we already kind of knew that. If it divides it evenly, then that's a factor, and then that means that if that equals 0, you can solve it. So x would be negative 3. Negative 3 would be a 0. The graph of the polynomial would cross the x-axis at that point. Okay. A little cartoon here for you, a little humor you can look at, and I got a little assignment for you. So enjoy that. Have a great day. I'll talk to you guys later.